from Feruglio. I'm head brewer here at Homestead Brewery. I joined Homestead a couple of months ago at the beginning of the brewery installation. I moved over from Temple Brewing in Melbourne, which is a brewing company that I founded about in 2006. My background originally was as an industrial designer, but I've also had many years working as a sound designer, a composer, sound engineer, animator as well. And I guess the thing that's common to all those different jobs that I've had and brewing is the combination of art and science, which to me brewing is very much very technical and a very scientific pursuit, but ultimately at the end of the day it's a big aesthetic component as well, and that's what really guides you in knowing whether a recipe is working right and whether you've got something that really stands out. For me, the attraction to come over to Perth from the East Coast was the scale of this project and the fact that the whole facility is all about quality. Quality beer, quality wine, quality food, and also having a very large market at the doorstep as well. So I've got an opportunity here, pretty well a free rein to brew the beers that I've developed a reputation for on the East Coast, as well as having a chance to work in with what's going on in the winery, using wine barrels for aged beers, and also for pursuing sour beers, which is an area of brewing that is of particular interest to me. So at the moment we've got 4 beers on tap, which is a German Hefeweizen that is brewed using a traditional decoction technique, which is quite rare in this country because not a lot of breweries have got the facility to allow decoction brewing. A very classic American pale ale, the Thunderbird pale ale. Also a Belgian pale ale, and Black Swan, which is a black IPA. There's several more beers in the pipeline, as well as some ciders and a perry. One of the particularly exciting things about this project is the actual brew house itself. It's a Kasper Schultz brewery. Kasper Schultz are a family-owned brewing manufacturing company based in Germany, and they are the oldest manufacturer of breweries in the world. Their quality of craftsmanship is second to none, and there's very, very many years of tradition that's behind the company. But the interesting thing for me is that coupled with that tradition and that craftsmanship is also totally cutting-edge technology. So I have the ability here to control the entire process from a on-screen panel where each of the valves can be activated just with a click of a mouse. So all the valves are pneumatic, and basically the whole process can be not so much automated but controlled from this point, which the advantage of that is that it allows you to have very tight control of the process, and that translates into consistency and replicability. The way you see it set out on the screen is pretty much exactly as the physical brew house is. What we have here is a mash kettle. So basically the process begins in this vessel here, which is represented on the screen by this graphic. Grain that is milled in the mill room gets conveyed via a conveyor and drops into the mash tun in combination with water that is heated to a particular temperature, and that creates the mash, which is the first part of the process. The mash is basically, looks like a porridge, I guess, is probably the easiest way of describing it. And that part of the process, which can last anywhere from about an hour and a half to 4 hours, depending on the complexity of the mash schedule and the kind of beer that you're making, basically is all about the enzymes that are present in the malt, breaking the starch down that's in the grain to create sugar. Sugar is what we're after, because sugar is what yeast uses to convert to alcohol and carbon dioxide. So this part of the process is all about basically converting the starch to sugar. From here we pump the mash to the top half of this vessel, which is represented over there, and this is a lauter tun. In there we have a false screen that's like a mesh bottom, and the grain is allowed to settle out and create a natural filter bed. So the bigger particles drop to the bottom, the finer particles as it goes up, and that allows you to filter the wort, which is the sweet wort, which is basically sugary water, out of that vessel and back into the original vessel we started with. It's been cleaned in the interim and then becomes the kettle. So in the louder tongue we rinse the sugars out of the grain, collect them all back in the kettle, boil it for an hour, and add hops at various stages of the process. The earlier in the process you add the hops, the more it adds bitterness. The later in the process you add it, it adds flavour, and right at the end it adds aroma. After the boil is completed, we transfer the worts through a system of pumps and pipe work into the bottom half of that vessel, which is a whirlpool. And it's very similar to if you've got tea leaves in a teacup and you spin it around and they all collect in the centre. The idea here is that the hop debris and any other protein break that's been created in the boiling process collects in the centre of this vessel here, allows it to settle out and clarify. Then we pump it back in again into the kettle, which is cleaned in the interim, and from there it gets sent out to the fermenters via a heat exchanger where it's cooled down to an appropriate temperature for the yeast to be pitched. So the whole part of the process is all controlled here. All pumps have got the ability to be turned on and have speed controls set on them. You have total control, as I said, total control of the operation from the screen, and it's an absolute joy to work with. Okay, well this is where the process begins. This is the mill room. We have our grain, our malted grain arrives in 25 kilo bags, as you can see on the floor there. And the recipe, which is basically a combination of different amounts of various malted grains, gets transferred into this hopper here. So basically the bags get tipped into the top. You can see it's got a screen there just to rest the bag onto. You load the hopper up, and then the next step of the process is to turn the mill on. The mill is basically two large rollers that with a very known gap of about 0.9 millimetres. Slide gate opens up, grain falls through, and this conveyor, which you see going past here, which is a chain conveyor, so stainless steel chain with polypropylene discs, collects the grain that's crushed. Once it's crushed, it's called grist. So the grist travels through this pipe work, goes for a bit of a journey around the top of the building, which we'll have a look at when we get out of the mill room, and drops into the grist case, which is this container here. So whole grain there, roller, mill, conveyor, grist goes into the grist case. Once it's all milled in there and we're ready to start the process, this valve opens up, the slide gate opens, the grist falls into the conveyor again, and it travels around by this motor here that drives the whole chain, and goes up through the ceiling and will come out this way, and I'll show you where it goes. You can see it travelling up there, over the top of the mill room. If you have a look at it up there, we can see it travelling along the wall to the top of the mash header. So, you can see it very clearly here. There's a slide gate at the top. That opens up. The grist falls down that tube, or malt pipe, and as it falls down, water, which is a mixture of hot water and cold water that's set at a temperature, the temperature is set on the screen, goes through a blending station, and the malt is basically hit with the water, falls into the mash tun. If we go upstairs, we can have a look inside. I'll just turn the lights on. So we head up on the brewing platform. So if we open this up, you'll see the grist falls through. There's some already in there which I put in there so you can see what it looks like. That gets wetted as it goes in. You have the agitator moving around at the same time, and a steam jacket at the base. So the combination of water and grist, heat from the jacket and the agitator basically creates the mash, which, as I said, is a bit like a porridge. And then from here it sits there through the various temperature rests while the enzymes convert the starch to sugar. From here, as I said earlier, we move across to the louder tun. sides here. And that's got some grain left in it, so you can see what it looks like. Slotted bottom. That fills up to about that level here. These rakes move up and down, and the rakes basically turn around in order to cut the bed to aid in filtration. So water is introduced here, and that's part of the sparging process back into the kettle. So where we were before, which is this whole section over here, that's called the brew house. Here we have a hot liquor tank, which is 5,000 litres, 50 hectolitres. This is a CIP station, which CIP stands for cleaning place. So there's a tank of hot caustic, tank of water, and by using the manifold here, we can direct the caustic or the water through all the pipe work to clean and sanitize the piping in preparation for the transfer of the work. If you look up the top, you can see it's a fairly elaborate system of pipes that carry hot water, cold water, works, glycol, steam, basically the things that we need in order to be able to brew. As we're passing through, we can have a quick look at this. This is our keg cleaner. Allows us to clean one keg at a time, but it's a total clean, so it cleans the outside, it cleans the inside, purges, steam sterilizes, and cools, and then ejects the keg ready for filling. We'll head across into the cellar. Okay, so our wort, which has come out of the kettle, comes down one of the pipes here, goes through this unit, which is called a heat exchanger. So we've got the hot wort travelling in one direction through all these plates, which are basically like a network of very fine sort of pathways. So the wort runs in one direction, and cold water runs in the other direction, and it chills it down. As it's chilled down, we also introduce oxygen via this system here. That allows oxygen to be absorbed into the wort because the yeast needs oxygen in order to grow. From there, we connect via a soft hose, as an example here, and then it's sent into one of these tanks, which is a cylinder conical fermenter. So these are 4,000 litre tanks. The brew length is 2,000 litres, so 2 brews are used to fill one tank. So we brew one day, then follow it up the next day. There's 6 fermenters, and we have room to add another 6. So ultimately there'll be 12 fermenters on site. So this gives you an idea of the size of the facility, and also the other thing too is the quality of the craftsmanship. So beautifully designed tanks, and they work extremely well.